Hi radio freaks, it's CT4558 here once again, having a go at the nanoVNA, and this time we're looking at the software, things to make it easier to do measurements and make your use of it a little bit more easier and flexible, as it were. So what we're going to be looking at today is tuning 11 meter CB antennas and how we can optimize the VNA to be set up to do these easy measurements in comparison to faffing around with touching a 4-inch touchscreen with sausage fingers or whatever implement you're using to try and select the menus on the actual device. This actually makes it easier. So what we're looking at here is this software called nanoVNA Saver, and it's at nanovna.com. If you go there, it goes to this website. It gives you a brief explanation as to what it does, but importantly at the bottom it takes you to the download page, which is at GitHub. If we scroll down a little bit, we'll see the versions here and source codes, and but what we're interested in for Windows setup is the Nano Saver version 0.2.2-1, and I suggest that you do take that version because there was quite a few bugs in the 2.2 version. So the 2.2-1 is the one to get, and it's simple. Just click that, it's an executable file, and it will set up on your laptop or computer. There are Windows, there are Android and iPad versions of this, but I've not actually used them yet. I'm just using a laptop at the moment in the field with this, and it'll just, for me, make things simpler. And I assume the setup's pretty much the same as for the Windows one as well. So once you've downloaded that, you'll get to this bit of software booting up here. Okay, so what are we trying to do? What are we trying to achieve? Well, the CB bands, as we can see here, are set up into 6 bands here. I'm talking about multi-mode, sort of wide-banded export radios. We have band A, band B, C, D, E, and F. And what we really want to do is try and optimize the frequencies that we're interested in using, and sort of tuning our antenna so that we get the most out of it and make it most efficient over the frequencies we want to use. So we could be using anything from 25 megahertz all the way up to 28.305. Well, then you'd be at one end you'd be in the amateur bands in the 28 megahertz bands, and then at the other end you'd be what they call pirating down in the 25 megahertz bands. So yeah, you know, I mean, me, I'm more interested in looking at 26 to the real top ends of 27 megahertz, but for the purpose of demonstration here, we're going to be looking at most of these, probably from band B up to band F, just so that the SWA representation, the chart, shows us you know, an overall picture of how the antenna's performing. So when we say bandwidths of antennas, literally it's as easy as this. We need 2 data sets to you know, to basically tune in an antenna. What we're looking at fundamentally is the lowest frequency we want to work and the highest frequency we want to work. And okay, I know this looks like a bit of spaghetti on the screen at the moment, but it will make sense. Now if we look at the blue, the light blue line that's going from bottom left right up to the top right here, that's what they call a long condition. Basically it will work in this instance at your lowest frequencies. You'll get a reasonable like 1 to 2, 1 to 5 here, and as you start approaching the mid band of where you want to get to, you're up at 2, which is acceptable. It'll work, hopefully won't damage your radio until you start getting up to 2.5 and above. So you're going to be using just half of the frequencies that you need to use. The next one is the narrow bandwidth, which is this pink line here. Now it's in tune. We've gone to the mid frequencies because what you'd normally do on an FM set, so it's just a 40 channel rig, you go to channel 20, and this is the sort of thing that you'd be sort of tuning your antenna for, so that in the middle it's spot on. You're getting a 1 to 1, 1 to 2 reference, and then maybe at your lowest frequencies, well, you know, you want a 1 to 5 or a 2, which would be this green line here. What you'd be looking at is that as an acceptable bandwidth, as it's called. In the perfect world, you'd be looking at the dark blue line, which is the broad bandwidth, and as you can see there, it's a very shallow sweep across the screen there, and it's well below 1.5, which is, you know, perfect in an ideal world. I'd rather that than have like this pink line. So that's what we're trying to do. Now this all depends on many things. It depends on your terminations, it depends on the coax, and it also, more importantly, it depends on the antenna you're using. More importantly, if you're using loaded antennas, what you'll get is more of this long condition where you've got very steep bandwidths, which you know, limit just how much you can tune your antenna to, and it limits you to how many frequencies you can use or how many channels. More expensive loaded antennas, I'd expect to see something more like this green line here, or in worst case the pink line. But for real high-end antennas, then you'll be looking at this broad bandwidth here, which, you know, you're looking at quite expensive end of the spectrum. Even home base antennas, you know, you're looking at expensive antennas to achieve that. So basically what we're trying to do is optimize what we can use our antennas for. Okay, so let's go back to the analyzer screen once again. So some important settings here. Let's just go through them briefly. To get this connected, if we go to the bottom of the screen, you see here the serial port control. So by now you've downloaded the software, you've connected your VNA up via the USB-C to USB, normal USB, into your laptop or computer. And here it's got the this will be blank. It's only showing COM6 because I've connected to it before, but this would normally be blank. If it's already found it, click the drop down menu and it appear in there. So just click, in this case, COM6. If it hasn't, do a rescan, check the drop down box. If it hasn't selected it, then you have to go to your device manager, identify the USB device, and then click to see which COM port it's selected for, and you can go into manage here and do it manually. So this is found mine on COM6, so we just simply connect to VNA. We can select that button there, and we can see straight away that it's connected. The green bar here, the sweep bar, has gone to 100%. That's just an indication that it's talking now to the nanoVNA. So we have our sweep controls at the top here, and this is what we're referring to when we're looking at that chart. The start is your lowest frequency, the stop is your highest frequency. It will then calculate what that center frequency is, and the span is, you know, the gap between the start and the stop, in this case 4 megahertz. So if we look at our sweep control here, we go into sweep settings. We've got 3 different modes of sweeps: the single sweep, continuous sweep, and average sweep. Well, a single sweep is no good if you're making adjustments to your antenna, because you could forget to manually get it to sweep again. So for adjusting the antenna, I always have it click to continuous sweep. The average sweep is when I'm happy with the results and I want to record it for my purposes. I go to average sweep, I'd put 10 in. Default is 3. I put 10 in, I let it sweep it 10 times and then record the result for future purposes. You drop down here, we've got our selected band. Now we're going to look at that and where to set them up, because the amateur bands are already pre-programmed into this. So to do that, we need to go down to the bottom of the screen, and it's this last option here, the display setup. By default, I have put on show lines. Return loss here, well, it's a loss, so I show that as a negative figure. Sweep colors here I've kept default. You can change the point size, the line thickness, and the marker size, how they're going to be represented on the graph. I've also ticked show marker numbers. so they equate to the marker numbers that we've put on the side here. Field markers, well, you normally get a triangle outline. If you put a field marker in, it just makes it solid. It's easier to see. When your eyesight's getting older and it's easier to point out on the graph. So I've selected field markers. Display charts, well, I've only got two. To keep this simple, you can select where you want them on the screen by, selecting in which order you want them. So the first one I've got is the VSWAR. The second one I've got is the Smith charts. I don't want anything else because it's not relevant to the measurements that I'm doing, but there are a lot more which we'll probably look at in a future video that you can do with this unit. Now if we look at our markers back on the main screen here, we've only got 3. Well, I want 4 because we're going to be showing our marker 1 will be the low frequency, marker 2 will be the mid frequency, marker 3 is the high frequency. So I want to add one, so we go to the bottom here on this display settings, add, and you can see it's put a 4th line in there. And that's it, and I'm going to change that to a color that will stand out on the graph. It goes a big hot pink, so we have red, green, blue and sort of pink there to show out where our traces are going to be. So back to the display settings, we go to the right hand side of it. We've got the chart colors there. The only one I've changed is the chart background from white, and I've made it grey so that it just stands out a little bit more once you've got the traces on there. I've left the others there. The font I've left default 8. And then we've got show bands. Show bands, well, as I said earlier, if we go into manage bands, you can see that the amateur radio bands are already in there. Now let me just take that out because that's not in there by default, the 11 meter one. So we got things like our 80 meter, 40 meter, 20s down to 10, 4 and 2, right down to 70 and 23 centimeters. Now we want to add 11 meters in there for CB. So it's as simple as this, add row, and I'm going to call it 11 meters. Right, now this depends where we want to look. I normally go a megahertz below where we're interested in, below and above. So if we're going from, say, what do we decide here? I think we're going from 25 to 29 megahertz. Well, I'm going to show on the display 24 to 30. So our low frequency will be 24 megahertz. Now you have to put this in as hertz. So 24 is 24 million in this case. So that's our start. Our stop is 30. There's just 6 zeros at the end. Why is that put 130? Oh no, sorry, I'm looking at the wrong one. So there we go, 24 to 30. And that's it, simple as that. Come out of there. VSWAR markers. Now this is another one. Now I'm going to have this red because that's going to create a threshold to us. What's the highest VSWAR that we want to see? It depends on your radio set. I think mine starts alarming at 2.1, so we can add it here. So the VSWAR value to show. So I'm going to say my threshold is 2 to 1. Okay, so that's 2.1 in here. So if we look at our, and that's the last setting we need to do on here. If we look at our graphs now, we can see that it's put thresholds in. These are our safety thresholds. So on the VSWAR we can see 2 to 1 line there, and on the Smith chart it's represented as a circle, as it's looking at the different impedance points versus frequencies on here that could differ. So it won't on a test load much, but it will when you start to connect the antenna, and we'll see that when we get back out in the field. So we head back over to here to our markers now. So marker 1, I think we've said, did we put 24 into move? So we're going to do 25, 27 and 29. So 25 is our lower frequency, 25.23456. It's important you put the megahertz sign in there, because if you don't, it won't distinguish it. It'll just go, not happy with that. Is it hertz, kilohertz, megahertz, gigahertz? So you have to put it in on here, which is, which is fair enough. So 25, 27 megahertz, and then our high frequency, the high end is 29 megahertz, and the 1 is a reference. The reason why I've put marker 4 in there is because I'm interested is the call-in frequency, which is the triple nickel or the 555, is 27555. there. Okay, done. And I lock it after that, so I can't change it. I can't make a mistake by accidentally going in there and changing things. Now I've clicked the locked icon there. So 25 megahertz, 27, 29 and 27 megahertz. That's that done. Sweep settings. Now I can call this, you know, if you're testing say 2 antennas, well, you know, and you want to label the graphs for what it is. In this case I've just call it 11 meter stereo perform of 5000, set that there, and that will put the titles at the top of the graphs there, so that's set. I've gone to continuous sweep now, which I don't want on quite yet because we've got to do the calibration. Down the bottom here we can select the band. Now we added 11 meters, didn't we? So if we go to our drop down table now, because it's the last one, it's not in number order, but it's put the 11 meter band in there. So what we do is check it, sweep span 24 to 30 megahertz. Don't forget I've got a megahertz each side, so that it just makes the representation of the chart easier to read. So now here we go, set band sweep, and if we check the sweep control settings on the top left hand corner there you go, they've changed. That's done. So our sweep settings are all done, our markers are in, and we're near enough ready to go. All we've got to do now really is to do a calibration. So we go back to the bottom left hand side, in amongst our settings here we've got the calibration screen. Now the reason why I like using this, because it just makes it so much easier. You haven't got faffing around with with like the touch screen on there, and you know, bad light, poor light, or fat fingers getting in the way. This makes it much easier. So if we click the calibration screen now, as you can see, you can do it manually here as well. Short, open, load, isolation through. Well, we're only doing the port 0, which is the S11, so we're doing the first 3, which is short, open, load. As you can see here, it's I'm going to reset it because I've already done one, but for the purposes of this, let's demonstrate it. So it will tell you whether it's calibrated or uncalibrated. The thing is, if you're using different leads, it will still say calibrated, but you still need to do it on, you need to do the calibration on whatever leads you're using. So back to our chart, what's it asking us? We've clicked the calibration assistant, and it says here, please connect the short standard to port 0 of the nanoVNA. Well, we know the one with the short is the one with a pin in the middle. It's not that one, it's that one. It has a center pin, it's all metallic plate in the back, which is shorted to the outer casing. So first of all, we put our barrel on. It's on there. We take the short circuit test piece, do it up finger tight onto the cable, and then we go back to the screen here. It says we'll connect the short standard on, press OK when you're ready to continue. So we press OK, it does its stuff, and when it's done it actually tells you that it's finished doing it. Now sometimes if you're doing it manually, you're doing it quick, you might take it off too quick and it's not made the measurement right. So this is a sure way of getting it right. So what it's saying now is that we have to put the open adapter on. So we take the short circuit one off, put that aside. Well, we know this one, the short one here, is going to be the open, because it hasn't got a center pin. There's no center pin in there. Screw that on, and when we're ready, click the OK button. Again, it will check it, do its stuff, and it'll prompt you one more time. And this time it's saying that we need to put the load on there this time. So let's take that one off. Well, normally you'd put this one on. I'm doing an experiment at the moment. I've got a precision load here, which is here, and I've got connected to this. I'm going to use the precision load because I need to just test something whilst I'm trying to kill two birds with one stone here. Oops, just bang my head on the microphone, why not? Right, so we're connected to load, which would be this one. Okay, so click that, that's okay. Right, so when it's done it, you've come up here and you've got two choices. It says the required steps for a 1-port calibration are complete. If you wish to perform a 2-port calibration, click yes. To apply the 1-port calibration and stop, press apply. Well, that's as far as we're going. We're going to the apply now. We'll do that. Save calibration. I've got a file here called 11 meg cal. Just overwrite that. That's done. Job done. All our calibration process is finished. So we can come out of there. What we can see on our graphs, we've got some changes already, because it's took in all the data that we've put in there. It's done a calibration. As you can see already, the SWA chart, the green line at the bottom, is a perfect 1. I will be expecting that, because if we look at our marker 1 data here, so if we look sort of on this data side, we've got marker 1, 2, 3, 4, where I've got my cursor at the moment. If we look at marker 1, well, it's telling us that's obviously 25 megahertz. That's at the lower end that we're looking at. It's telling us that the impedance is absolutely bang on, 50 ohms impedance, and the VSWR is 1, which is perfect. You know, if you ever got that, then you've got some super duper antenna. And it's looking at a return loss there, you know, which is mega 39. What we've got here, yeah, all perfect on there. Now I want to test something. I'm going to take that precision load off. Which I'm doing here. So there's my precision load off. Put this barrel back on. Right, it's going to be interesting now to see what we get. Now I've got the standard one with it. It's not going to be much in it, to be honest, but you know, I just like seeing a little bit of perfection. If you've got a precision load, when you get to it, use your precision load. Don't use the standard one with it. They are cheap 50 ohm loads. They're not precision. As you can see here, the SWA line at the bottom has gone up, and even if I calibrated to that, it will be about what it is there, 1.042. The impedance isn't so good. You can see it's 52. So that's why I've specifically used a precision load on that. Not I'm showing off, I just wanted to kill two birds with one stone. After all, this is my 4th attempt at doing this one, so I deserve a little bit of a treat at the end there. So hopefully that's made it a bit more self-explanatory to you. What we're going to do next, we're going to take the laptop out, we're going to get out in the field, and we're going to put this all into practice to see how easy it is just using a laptop, recording the measurements, looking at what you need to do, looking at the screen, whilst you're outside faffing around, shortening and lengthening the antenna. Okay, so let's when it stopped raining, get out there and let's get these antennas analysed.